Hello, welcome to take 100 of the AP Cal Problem 6 FRQ section of the 2015 exam. So let's get right into this. My name is Christopher Romero and this is problem 6. Consider the curve given by the equation y cubed minus xy equals 2, and it can be shown that dy over dx equals y over parentheses 3y squared minus x. So A. Write an equation for the line tangent to the curve at point at negative 1, 1. So let's highlight the importance of this question. So first thing we should highlight would be the equation given, y cubed minus xy equals 2, and then the equation for dy dx. This will all be very important. So we're looking for the line tangent and at the point negative 1, 1. So first we need to find the slope, which will be represented by m. So m is equal to dy dx, and this should be all taught to you by now, I hope, because this isn't a lesson. This is more of a tutorial on how to do this problem, so I will not be going over these concepts. So m will be equal to dy over dx, which means we just plug in the values of x and y for y over parentheses 3y squared minus x. So we plug in y will be 1, so it will be 1 over 1 squared. 1 squared will just be 1 times 3 will be 3. So I'm going to be skipping steps like this because I am hoping that they're pretty self-explanatory steps. So continuing on, minus x, so it will be minus negative 1, which will just be plus 1. So 1 over 3 plus 1. So this all simplifies to 1 over 4. So this is our slope. Now what we want to use to find the line tangent is the equation y minus y1 equals m parentheses x minus x1. We have the points and we now have the slope. So let's just start y minus y1, which is just 1, so minus 1, equals 1/4, because that is our slope for this point, and then parentheses x minus negative 1 would just be plus 1. So you do not need to go any further than this to get full credit. You can, but it will not get you extra points. This is all you will need to put down for all the points possible on this question. So moving on to problem 2. Let me just erase some things here. And let me just move question B up here. By the way, you guys, it's 1:09 a.m. So I'm sorry if I sound a little bit sleepy or anything. It's really late. I just didn't want anybody interrupting this video. So moving on to question B. Find the coordinates of all points on the curve at which the line tangent to the curve at the point is vertical. So all that confusing statement is just saying where dy dx is undefined, or where dy dx, the slope, is vertical, which means where it is undefined. So the equation y over parentheses 3y squared minus 1 will be undefined when the denominator equals 0. So let's just set that up. 3y squared minus x equals 0. Now let's just solve for this. 3y squared will equal x sorry, it's not an x, it's 0. So that's an x. And then now we need to use the original equation to solve for y. So we just plug in the value of x, we plug in 3y squared, so it would just be y cubed minus parentheses 3y squared and the parentheses times the y is equal to 2. So now we just solve for y, so this will be y cubed minus 3y cubed equals 2, and then y cubed minus 3y cubed equals negative 2y cubed equals 2. Then we divide by negative 2 both sides, we get y cubed equals negative 1, and then y will be equal to negative 1 because the cube root of negative 1 is just negative 1. And if you don't believe me, you can check that out on your calculator. So now that we have a value for y, we will find x by just plugging into the equation here. 3y squared equals x. So since we know y equals negative 1, we just set it up 3 negative 1 squared equals x, which I hope I can just simplify really quickly into x. X will be equal to 3. So the point will be just it will just be 1 point. It says all the points, but it will just be 1 point in this situation. It will be 3 negative 1. And this is all the work you need to show to get all possible points, and all credit for this part of the question. So now let's move on to part C. And moving quickly, you can feel the math. I'm making no sense, you guys. I'm really sorry. It's 1:14. And I meant to function is early or late, whatever you consider, whatever you prefer. Maybe you're more of a half empty glass or a half full glass. It's all up to you. But now moving on to problem C. So evaluate d squared y over dx squared at the point on the curve where x equals negative 1 and y equals 1. So d squared y over dx squared is just the second derivative. We are given the first derivative in the original part of the question, so using the quotient rule, we can find the derivative. And if you don't know what the quotient rule is, just look in the book, look it up. But I am not here to explain this. I said it before. I'm not here to teach this. I'm just here to explain the question. So going through this, d squared y over dx squared, that will equal to, the first part will be 3, the bottom, that will not be taking the derivative just yet, 3y squared minus x in parentheses times dy, doesn't look like a y at all, over dx minus, because it's a quotient rule, remember, minus, not plus, minus y, the top, minus derivative of the bottom, which will be 6y you know, 6y dy dx. dy dx minus 1, because the derivative of x is just 1. All over, remember, once again, this is the quotient rule, so we're dividing here by the bottom squared. So dy minus x, no, 3y squared minus x. Sorry for that mistakes. So this looks very intimidating at first, but it's actually quite simple. We have all the values for this. You may be wondering, what is dy dx in this situation? Well, we plugged in the points. These are the exact points plugged in part A. So dy dx will be the exact same as it was in part A, which was 1/4, if you remember. So we have x equals -1, y equals 1, and dy dx will equal 1/4. So now let's plug in all of that, and we will get 3 times -1 squared, no, times 1 squared, minus -1, which would just be plus 1, times 1/4, minus 1 times parentheses 6 times 1 times 1 times 1/4 minus 1. That is just a big mess right there. Yeah, and then the bottom will just be 3y squared, which is just 1 squared, plus, no, minus x will just be plus 1. 3 plus 1 squared. So I'm going to skip all these steps. You should be able to add and simplify and multiply all by yourself, and your final result will be 1/32. And those are all the points. All the points will be given from finding knowing the quotient rule, from plugging in points such as dy dx and y and x, and then about 1 point will be given for the answer. So don't stress too much about the answer. If you get it wrong, it's just 1 point. What you really want to get right is the quotient rule, and then what you plug in for the quotient rule. Those are where the main points are, so focus on those. So thank you guys for listening to this video. I hope it was helpful. This was a very tough question. I would say it was probably one of the toughest in the exam, because these dy dx questions are always, not always, but most of the time the toughest in the test. But I hope this was helpful, and this was Chris signing off.